Sine rule. What is sine rule? Triangle ABC. Angles are denoted by capital letters. Sides. So opposite to angle C, we take side with small letter C. Opposite to A, small letter A. And opposite to B, we will take it B, small b. They can be also named as CB, look AC and BC. Well, this is about triangle. Now what is the sine rule? So these equations are called sine rule. These ratios are called sine rule. There are three ratios: A and sine angle A, B and sine B ratio, C and sine angle C ratio. They are all equal. You notice that on the upper side they are sides, and on the lower sides in the fractions they are sines of angles, respective angles. Or look, BC, AC, AB. If this is BC, under it the sine will be A, the missing letter. If this is side AC, then under it will be sine of the missing angle B, missing letter, sorry. If this is AB, then under it will be sine C, which is missing in the numerator. So it's easy, quite easy. A very beautiful symmetric pattern is seen in all the ratios. Let's solve example 2.1, where ABC is required to be solved for all its angles and sides, while two of the angles are given, and one side which is given as BC equals 13 cm. Let's go for example 2.2. This time we have one angle and two sides in the given triangle ABC. This is the triangle ABC. A 21 degree, side AC 17 cm and side BC 14 cm. So we are doing this with the help of the sine rule. This is sine rule. We can also write the sine rule in this shape, because small letters A, B and C representing sides. So small a means BC, small b means side AC, and small c means side AB. Plugging in values, and after applying values, we take the first two ratios equal, and from here we can calculate value B easily by cross multiplying, then divide by 14, then we go for its simple form of the calculation. And now sine inverse of the right side. But if you see sine b is equal to 0.4352, which is positive, and sine is positive in the second quadrant. In second quadrant and in first quadrant. So sine can have two values. First quadrant will be here, which is this, and in the second quadrant it will be 180 minus this, equals 154.20 degrees. After this angle, so there are two cases. B got two values, case 1 and case 2. We solve for case 1 first. We know that sum of total angle measures is 180 degree. Plug in A and B value. B we recently calculated, and then this is the final answer for angle C. Now all of the angle have come out in case 1, and we can go now for the remaining side. So from the last two ratios we can calculate C. So C is 28.47 C. So this is first solution. B is 25.8, C is 133.2, and AB is this. Let's come to case B. So again we calculate C with sum of measures of angle triangle. Then like the first case we calculate C, then using the sine rule, plug in value, and again from the last two ratios we can get C value. So solution 2 is this. So in sine case we usually find not usually, but there can be cases. Let's take another example, 2, 3. Again one angle and two sides. Sine rule, we write in another shape in terms of complete side names, then plug in values, taking the last two ratios equal, it gives B, sine B, and B inverse. Again sine is positive in the first quadrant and in the second quadrant, and so B can be this and this. Well, so again it's a matter of cases, but if we look at the last choice, 150.61 degrees, if we add this with the given angle 42, which comes out more than 180 degrees. So in this case we don't have two situations, only the B angle is 29.39 degrees. So 150 is rejected. Well, and that is why I told you in the previous example that it's not necessary all the time two cases. So we should see this kind of situation. If the sum of two angles is coming more than 180 degree, then we should stop there. So we are not taking the other choice, we are taking only 29.39 degrees choice. Okay, and in term of B, which is in term of B to 29.39, we can calculate A, which is less than 180 degree. It's fine. Plugging in value, and in the first and secant ratios, we can calculate A. So the only solution is A, B, and side A. Another example, 2.5, again one angle and two sides are given. So it looks almost similar. Sine rule, plugging in value. From the first and the last we can calculate angle B, and B is this. Well, sine is positive in the first and second quadrant, so sine can be, B can be this, and another B can be 128.91 degree. This is for the second quadrant. Well, case 1, because both are possible. Case 2, case 1, from 180 rule we plug in values, we get A. Now we go for side A. From the first and the second ratio we can calculate side A. So first solution is A 88.91 degrees, B 51.09 degrees and side A is 29.55 cm. Similarly for case B, plugging in value in the first of all 180 rule, then plugging in value in the sine rule. From the first and the second, again we can go for side A. So side A is 50.69 cm. So another solution is this one. This exercise, I hope now you can do it, and almost all of the cases have discussed in these examples. This is a kind of homework for you. You should try them. Solutions are given, answers are given in the book. If you don't have book, I have uploaded this chapter or block. You can see from the Moodle. Thank you.